Okay, I'm back, and in the same way, when we started off with geology, we talked about what elements were in the earth and then what elements were in the crust of the earth. Well, now we want to start this lesson by talking about what elements are the most common in the various atmospheres of the planets in our solar system. So let's start off with those terrestrial planets. And Mercury, very oddly, has a lot of oxygen in its atmosphere. So it's got 42% oxygen. Now, don't get the idea that that oxygen came from plants. So that's what happened on Earth, but they think that on Mercury it does have oxygen in its atmosphere as a result of the oxygen that came out of some of the rocks that are on the planet Mercury. But for all intents and purposes, we're going to say that Mercury has such a thin atmosphere that we don't really care about the atmosphere of Mercury. Okay, then let's look at Venus, and you can see that its main component is carbon dioxide. And then look at Mars. You'll notice it's almost identical. So the major component of the atmosphere of Mars is also going to be CO2. The difference being that on Venus there's a lot of CO2, a very thick atmosphere, where it's the exact opposite on Mars. If you look at Earth, though, you'll notice that we have two major elements in our atmosphere. So we have a lot of nitrogen, and then we have a lot of oxygen. So later we'll talk about where did that come from. And then what I want you to see about Jupiter, Saturn, Uranus, and Neptune is that the primary gas is going to be hydrogen and helium with a smattering of other elements. Okay, so that's our starting point. Those are the elements that we've got to work with. Okay, now what we want to do is concentrate first on Earth. So what is the current composition of Earth's atmosphere, and then what would it be if there was no photosynthesis going on? So hopefully you knew that photosynthesis is what makes oxygen, so that plants and bacteria that photosynthesize, they take carbon dioxide, absorb it, turn it into sugars, and then as a waste product, they emit oxygen. So that if you were to look at the atmosphere of the Earth currently, it has a lot of nitrogen, 78%, 21% oxygen, and then about 0.04% carbon dioxide, and then it's got some methane and some other elements and compounds in it. Now let's look at what would the Earth be like if there was no photosynthesis going on. And you might be looking at that green bar there and say, oh, the Earth would have a lot of oxygen because that bar is the same length as the other bar. But no, notice up at the top it says logarithmic scale. So that means that every one of those tick marks, it goes down by a factor of 10. So that if there was no photosynthesis, then the Earth's atmosphere would only contain 0.1% oxygen. But notice that it would be 99% what? Carbon dioxide. Does that sound familiar? Yeah, that's basically the composition of Venus and Mars. So if there was no photosynthesis going on, we would have an atmosphere very similar to Venus and Mars. Now, our atmosphere would not be as thick as Venus, and it wouldn't be as thin as Mars, so it would be somewhere in between. Okay, so I wanted you just to see that. And now let's talk about how an atmosphere changes. So the original atmosphere of a terrestrial planet is going to be composed of hydrogen and helium because those were the two main elements that were in the big gas cloud that became the solar system. So Earth's original atmosphere would have consisted of hydrogen and helium. But what do we know about hydrogen and helium? They're both very light gases. If you take a party balloon filled with helium and you let it go, it goes up into the air. So it wouldn't have taken Earth very long to lose its hydrogen and helium, probably 1,000,000 years, maybe even less than that. So now let's go to Earth's secondary atmosphere. So Earth's secondary atmosphere, now this is going to be true for Earth and Venus and Mars. So we think that all of those planets originally had a secondary atmosphere that would have been composed of water, carbon dioxide, sulfur dioxide, hydrogen sulfide. Hydrogen sulfide is that thing that you get that rotten egg smell from. And then ammonia and methane. So all of these kinds of gases come from two places. One, they're erupted out of volcanoes, and two, they're found in comets. So as the Earth and Mars and Venus got pelted by comets, and then early in their history they had volcanoes, more numerous than they do today, those gases were released into their atmospheres. All right, now let's go to Earth's tertiary atmosphere. So now Earth is going to be the only one of the terrestrial planets that is going to have a tertiary atmosphere. And so our tertiary atmosphere is going to be composed of oxygen and nitrogen with trace amounts of carbon dioxide and water and methane. So where did all of those other compounds go to? Well, first of all, the water in Earth's atmosphere condensed to form the oceans. Now, there's still water in the atmosphere, but not nearly as much as in the Earth's oceans. So the water in the atmosphere cooled off, turned into liquid water, rained onto the surface of the Earth, and eventually we got our oceans. Okay, then the oceans absorb carbon dioxide and precipitate it as calcium carbonate. So that's where limestone comes from. So that on Earth, something like 95% of the carbon dioxide that was in the atmosphere is now in the form of limestone inside the Earth. Whereas on Venus, that carbon dioxide is still in the atmosphere because it lost its oceans. Okay, now this next one is what happened to the hydrogen sulfide. So that's the H2S. And so there are some kinds of bacteria that love to eat it. And so that's a picture of Yellowstone National Park. And if you notice, you see those different colors that are surrounding that geyser. And so what those different colors are different kinds of bacteria that eat the materials that come out of the geyser. And you'll notice that they change color because they're different kinds of bacteria that like different temperatures. So the ones that are up closest to that hot water looks like those are the greens and the yellows, but the ones that don't like the hot water are further away. Okay, other kinds of bacteria like to eat ammonia, and so then that is going to, they like to eat it and then turn it into nitrates. And then the picture there off to the side is soybeans. So those are the roots of soybeans. And if you look carefully, you'll see these little nodules that kind of look like little white peas. And so what happens is this particular kind of plant houses bacteria that turn ammonia and nitrates, ammonia into nitrates and water. So it's a good deal from the point of view of the bacteria, because they're being fed food by the plant and they're being protected. And it's a good deal for the plant, because the plant is getting free nitrates, which is essentially fertilizer, from this bacteria. Okay, now the big one though is, notice that photosynthetic life. Now this could be green plants, it could be also photosynthetic algae, and also it could be photosynthetic bacteria. So you have different kinds of things that can photosynthesize, and so they replaced carbon dioxide in the atmosphere with oxygen. And then finally, well, where did the nitrogen come from that's in our atmosphere? So the current theory is that it's given off by subduction zones. So a subduction zone was when a lithospheric plate went underneath another plate, and then when the material comes up to the surface, it comes out through a volcano. And so they think that these subduction zones are places where nitrogen gas is given off. And since nitrogen gas is pretty unreactive, it has just gotten more and more and more of it in our atmosphere. Okay, if you are interested in the timeline for all of this, then here it is. So this shows, as a function of time, how the atmosphere of the Earth has changed. All right, so in our next section, we are going to talk about the structure of the Earth's atmosphere. So I'll be right back.